You hear me? I hope so. If you can't hear me, I hear the speaker, so it works. Okay, welcome to my talk. My name is Andreas, and I will talk about device-tailored compositors with the QtWayland compositor framework. It's a very long title, and I will explain it to you in a minute what I want to tell you. Shortly about me, you can find me in several IRC channels. I'm with the KDE project since about 7 years. I did a PhD in some theory stuff, and today I'm doing completely different things at Class E Systems, a company that's doing these big agriculture machines with the really nice green, much nicer than the green of the competitors. And we are hiring, by the way. But this talk is somewhere between my KDE work and my professional work. It's about a really, really nice technology that you can use for embedded devices for displaying stuff from several processors, so from several applications. With this talk, my goal is to give a short practical introduction to this framework, tell you how to use it, how you can experiment with it, and make you eager to really use it, since it's extremely cool. I'm not from the QtWayland compositor developers. I know them. I chat a lot with them, but I'm not completely from them. I'm looking more from the really usage point of view on these frameworks. Okay, it's always very hard to talk about embedded stuff in the car industry and the automotive industry, so I thought about a really nice practical example where I won't get any problems about this funny confidential stuff. That's my kitchen. And assume I want to have an embedded device somewhere here that helps me in the kitchen. Yeah, what do I want to have on that embedded device? I want to have some applications that help me, for example, for cooking eggs, and for cooking a tea, and maybe the current time, and some other applications. I want to have a really nice seamless UI between these applications. So no borders, they should be really nicely aligned. I want to have some touch gestures, like swiping to the left, to the right. And I'm using some nice hardware, like Raspberry Pi or some other embedded hardware that has a GPU, so a little bit of 3D acceleration. That means I can use QtQuick, which is important later in this talk. Actually, nowadays you can use it without 3D acceleration. I'm not sure about this framework, but it's always a plus. And, well, as I said before, the important point about having several applications there is I have several processors that I somehow have to compose on the screen, so I need a compositor. So usually a Wayland compositor. And yes, everything what I explained there is much more trivial to achieve. It's a simple process, one process application. But, well, if you're looking at the modern use case in the automotive industry, or for example in the agriculture business, where we have really, really hard requirements with really heavy applications running on this machine at the same time that you have to compose, so much harder use case actually than in the automotive industry. Well, you want to have several processes there. So, I'm going to draw a small picture about what I explained to you. That's the size of a Raspberry Pi display. I want to have the applications aligned horizontally. I want to have this swipe gesture, left and right. I want to have a navigation information, so where I'm currently on my screens. And I want to have some notifications that should be sent from the applications and shown in the compositor, which is actually not that trivial as it sounds in the first hearing. Okay, and the rest of this talk is how can I create such a device with the QtWayland compositor framework. And actually I want to show a compositor that fits on one slide for achieving this. So, a little bit about Wayland. I assume that all of you heard that name at least once. It's a protocol that explains how you communicate between a client and a display server. So between an application with a window or several windows and the application server, the display server, which is a Wayland compositor, which is responsible for putting the windows somewhere on your screen and also for import handling and so on. So it's really about this communication. In the embedded world, since several years, it's the default standard. Nobody is using X anymore, at least I don't know about anyone. There are a lot of Wayland compositors, since it's simply protocol. So you can implement your own compositor. You can find the FOSDEM, that's the reference compositor. You can find in the desktop environments a lot of different compositors. For example, we have our own one, Quinn and KDE. GNOME has its own, Enlightenment has its own. I actually also encountered proprietary compositors somewhere in the field. And well, it gives you a basic protocol. Sometimes you need a little bit more. You want to have your own custom protocol extension. For example, in KDE we had the extension for snapshots, that you can ask for a snapshot of all the windows together, how they are currently displayed on the screen. That's a simple protocol extension. How a client communicates with the server. It says, I want to have a picture, can you store it somewhere? Those protocol extensions are, well, defined in a well-defined standard. Then you have some tooling that creates boilerplate code and connects it to your programs, and then you can simply use it. There are different available shells, which is, well, it's kind of which language do you speak to your compositor. The default one is this WL shell that was introduced in Wayland 1.0, and we have the XDG shell, which is the actual successor, and we have in the automotive field, especially this Ivy shell extension, which gives you a small, tiny interface how you can communicate with your compositor, and with the goal that that's interchangeable. You can take any compositor that speaks Ivy shell and you exchange it. However, that is really limited in what you can do there. And in my use cases, it never worked until now. So I looked at this framework, at this QtWayland compositor framework. With this framework, I don't know how many of you used QtQuick before. I see a few hands. It's a declarative language that, well, it's a declarative language, looks like a little bit like JSON, where you say what you want to have. Like, I want to have a rectangle, then you have a rectangle. And you can do the same, or you can now do the same with the QtWayland compositor framework. You can say, I want to have a compositor, I want to have an output, I want to put my window somewhere in the output, and everything works nicely together. So it's really the power of declarative language for creating such things. And this QtWayland compositor framework, since I think 2 weeks ago that we have this Qt 5.8 release, now we have this. For these protocol extensions, I talked shortly about last slide. You can also get a little bit more tooling, that you get Qt-style C++ API, not only the C-style APIs with this framework. It's automatically generated there. You can, of course, what you want to have several screens if you have a device and several monitors. That's nice to have. It has, it implements all these different shells I talked about, and the core is actually stable and, well, it's there since several years. It's, I think, at least since Qt 5.0, only the API is new. So it's a really stable piece of software or framework that you have here. And what they did here is really this really nice Qt Quick style API to use it in a really nice way. I shortly talked about this Ivy shell extension. My problem recently, or until now, was always that it's only fits, at least from my point of view, for really static settings. Like I have a screen and I have some windows that I want to put statically somewhere on the screen. That's really nicely we're doing with Ivy, but with global gesture control and other stuff I wanted to have, it didn't work. And for such requirements, I would actually have to work directly on my Wayland server, and I didn't want to hack on FOSDEM, since it's really not my field and not my experience, what I can use there. So, looking a little bit more deeper what we can do with a Wayland compositor, or how a possible system architecture would look like. We have several applications, we have a compositor, and possibly you also have a, well, intermediate application, which I simply call a shell. So you have the apps. The apps are talking to the Wayland compositor by the default Wayland protocol. Within Qt, it's abstracted by the Qt platform extraction layer. You call it if you simply use -platform Wayland, and it works magically. You can also use your custom protocol extension, for example, for notifications, which I will introduce in a few slides, how you can add a small extension for notifications. Or you could also have a proxy in between. This is architecture on the right side, where you have a shell that gets all information or all these IPC information by some mechanism, and then that is the only real Wayland client that's talking your protocols and talking to the compositor. If you want to have a little bit more stability and encapsulation of the really critical stuff, since you never want to have your Wayland server being crashy, and you can put your little bit more critical stuff in the shell. I will look at this more simple architecture here, but the other one is also really simple to achieve. And, well, that's the main slide of this talk. That's my compositor for what I told you. I will talk a little bit about it on this slide, and then I will go a little bit deeper in the next slides. So, like I said, it's declarative. I did some imports for the basic stuff I need there. Then I said, well, I want to have a Wayland compositor, and then I want to have an output. Like, well, you want to have something on your screen. Here below, I have the WL shell. From that, I get the notifications, hey, there's a new surface, so a new window from application. And if I get such a window, I put it into a list model. Since that's nicely to use here, since I want to have the windows aligned next to each other, and I simply use the default Qt stuff for aligning items, rectangular items, somewhere on the screen. And I put it in a wrapper, it's called a shell surface item, and then Qt did everything for me, what I wanted to have here. But look a little bit more deeper into it. So we always have, or typically we have as a root this Wayland compositor. It's the actual representation of the compositor. In the background, everything is created for your Wayland compositor. And usually you should have an output. Otherwise you don't see anything. You should have a shell extension to get information that you have, that there are surfaces to be presented. The shell extension actually gives you information sent by the Wayland protocol. Here we have this WL shell, and we get the information there's a surface created. If I add my own custom extension there, I can add several extensions there. I can also get these informations, that I get a signal from application like your tea is ready. And we have other shells, but for the embedded use case, it's usually enough to simply use this WL shell, since we don't have a fully fledged Linux desktop here. Then we have the surface item and the QtWayland quick item, which are nice wrappers around the surfaces. So a surface is simply a field where you have some image data, and you want to put it on your screen. So you put it into such a wrapper, and then you can use it exactly like a typical Qt quick item. So that's the actually nicest thing about this whole technology. You handle windows like they are not windows, but simply rectangles with some stuff on it. And so a simple Qt quick developer can simply use it with all his intuition from what he usually does. Just consider, well, this surface is a rectangle, and I move it, and I do some animations on it, I enlarge it, I turn it, I put a shader on it, and all the stuff you can do. And that's really nicely, since you're working on Compositor like it's a simple process application with a little bit of Qt quick items that you get from somewhere. And that's the real power of it, that you can get on a high level really nice effects, really nice implementations without being bored with all the technical stuff below. Yeah, and well, what do I have here? Yeah, it's doing the visibility, it's doing the input stuff, so I can deactivate the input stuff, I can hide it, I can show it. And, well, it's really acting like a typical item. And of course, I need an output that's simply a rectangle area where I show my results of the compositor. And of course, I can have multiple of them. I talked a little bit about protocol extensions. For my use case, I said, well, I want to have notifications that my clients send there, like, your tea is ready, your eggs are ready, time to go to bed, or whatever my applications want to show it globally on the screen. And what you see here is a typical XML snippet which describes such a protocol. You can use typical Wayland tooling, the Wayland scanner, to get the binding for it. Here I'm using the Qt tooling, since I get also a C++ API. I can run it over it, and of course, well, all the code and the talk slides and everything is available on GitHub with all history. And well, what I said, you are running your tooling over it, you get your boilerplate code, your bindings, you put it into your applications, and it works. And so you can have your typical signals and slots where you can connect to, where you can send data, and everything works. And, well, actually that is what I did from my initial well, idea what I have for my kitchen application. That's, well, I got a notification, your tea is ready. I have 2 applications running here, and I will try if I get a live demo running here. Let's start my compositor. There's a compositor. And an X application. Let's see. Oh, there's an application. And maybe a T application. There it is. And maybe another egg application. Then we have a little bit to see here at my navigation bar. And I can move it. And, well, go T time a little bit down. I can simply run the applications, and, well, it's easy to achieve something like that. And if I would have had time, I could have put it on my Raspberry Pi, and it works. I did several similar things while the tea is ready. And it's really nicely working also on a lot of embedded devices. So I was faster than I thought, so we have a little bit of time for question later on. You can already start thinking. So again, what I wanted to show you in this talk is where this new QtWayland compositor framework, which allows you to simply create a Wayland compositor tailored for the specific use cases and wishes for your embedded device. You don't have to take a stock Wayland compositor that is maybe cumbersome, makes problems with Qt event loops, which I also have seen with proprietary compositors. You can tailor it directly to the user interaction concept your designers give to you, since it's actually Qt Quick Designer work, what you do here. The compositor I created here, it's literally a one-day job to create such a compositor. Even the first time I worked on it, well, at that time I took 2 days to get it working. That's really nice thing, and you can use it for fast prototyping of compositors. You can also use it, well, for doing real compositors that you want to use later on. And well, the power, as I already said several times, I think the power of this framework is that it gets the right abstraction to get you into a position where you create a compositor or user interface without thinking about all the complicated Wayland-related stuff far below the surface. But you can really look at the UI compositing, and the overall interactions you want to have there to get a really cool and a nice user interface. And the best thing is really to try it out. You find my code here. You find a lot of example codes in the Qt repositories. And yeah, there's also a little bit of documentation. However, the examples are sometimes more helpful currently than the documentation, I think. Okay. And there are a few slides, 3 pointers. Johan did a nice talk about the same framework at QtCon. There's the online help and, most importantly, the IRC channel. Okay, thanks a lot for your attention. Any questions? Yes?
Have you used it also across multiple displays?
I saw an example in my office, not yet, but it really works that you have well, several displays and several outputs. There are also example codes for exactly that use case, the multiple screen demo. There are Qt repositories. Yeah.
Can the compositor distinguish different types of screens, like a tablet mode or Windows full desktop Windows mode?
Again.
So if you have the compositor trying to composite in a tablet mode, would it composite the same way as it was desktop mode? In desktop, for example, we have like way to English, close and maximize.
Well, just implement it into your compositor. What it should do. Well, that's your freedom. You have the compositor framework, and then you look at what you want to see there, and the compositor should handle it. It's well, it's your task to create all these effects in the compositor. It only gives you a framework to use it with Qt Quick, and then you can implement it. Okay, no more questions, and thanks a lot.